The previous sections with 4.2 and 4.3 had a lot to do with the area. And so I wanted to do a video. This is the last part to section 4.4. We find area, but instead use the fundamental theorem of calculus, basically integrating the definite integral using integration rules rather than having to use the limit definition. So these are two examples I'll go through. So we're going to find the area for the region bounded by the graphs of the equation or equations. In order for the definite integral f of x dx, which we know by fundamental theorems, capital F of b minus capital F of a, where capital F is the antiderivative. So that represents area if our function rests above the x-axis. For whatever region that we're dealing with, rests above the x-axis and a to b. So a definite integral we know can be negative, but in order for it to represent an area under a curve, since area is positive, we need the function itself to rest above the x-axis. So for number 41, I'm going to just try to sketch a rough, this just be a rough sketch of the graph. Just to visualize what's going on. All right, so they tell us it's going to be bounded for these equations. And whenever you have, like this case, we have x equals 0 and then x equals 2. Anytime you have x equals some number, that's a vertical line. But if it says x equals 0, that's actually the equation for the y-axis, because the y-axis is a vertical line. If it was y equals some number, say y equals b, that's the equation for a horizontal line. So in this case, they give us y equals 0. And just like how x equals 0 is the equation for the y-axis, y equals 0 is the equation for the x-axis, because the x-axis is a horizontal line. And on the x-axis, all the y-coordinates are 0. All right, these are just stuff we should already know, but just go ahead, I'll go ahead and say that. So for my graph, and we have y equals 5x squared plus 2. So we know we have a quadratic function. Quadratic function, right, it's like f of x equals ax squared plus bx plus c. So we have our leading term is the exponent of 2, so it's going to be a parabola for the shape of the graph. This produces a parabola. And it's either opening up or it opens down, and that depends on the leading coefficient. If a is positive, then it opens up. So if it's negative, the parabola opens down. So for our case, we have y equals 5x squared plus 2. A is 5, so we know it's going to be a parabola that opens up. And also the last value, 2, that gives us the y-intercept for the graph. So the y-intercept is 0, 2. All right, so our region is going to be bounded between, as far as the parabola, bounded from the x-axis, the y-axis, and the horizontal line, or sorry, the vertical line, x equals 2. So I'll draw, this is just going to be a rough sketch. Let's say this is 1, and this is 2, and on the y-axis, I'm not going to go as spaced out as I am for the x-axis. All right, so for x equals 2, that's this horizontal, or sorry, this orange vertical line. And we know x equals 0 is the y-axis. So that would be the vertical line. So this is the y-axis. If I put that all in yellow, that's going to be the x equals 0. And then it also tells us we're bounded with y equals 0. Y equals 0 is the x-axis. In other words, we're dealing with the first quadrant. We are restricting our region to be in the first quadrant. So we know we have a parabola for the shape of y equals 5x squared plus 2. And we know the y-intercept is 2. So let's say this is where it crosses the y-axis. And we know it's going to have some parabola shape. And so eventually it's going to cross the orange line. So I'm just making this up. So this is, again, just a rough sketch. So it's going to eventually cross that orange line. So that's y equals 5x squared plus 2. And so it keeps going forever, and probably want to know, where does it hit the orange line? So that's saying, where does y equals 5x squared plus 2 intersect that vertical orange line, x equals 2? And you just plug 2 in for x. All right, so that's 5 times 4 is 20, plus 2 is 22. All right, so the coordinates of this point are 2, 22. All right, and then the coordinates of this point is 0, 5. All right, so we're restricting ourselves to the area of the region that's bounded, and it's going to be this as our region. So we want to find that area. right. And we know the integral from a to b of f of x dx, that's going to give us the area because our region's above the x-axis. And now what a and b are, well, we're going from 0 to 2 as far as the horizontal range, starting at 0, going to 2. So this would be equal to 0 to 2. And then what is f of x? Well, that's our function. And our function's y equals 5x squared plus 2. So this is our function f of x that lies above the x-axis. All right, and we just integrate this. All right, all I was doing was just showing a rough sketch of the graph. It's this parabola, and it's going to bound it in the regions where we have the equations where it's x equals 2, that's a horizontal line, that's an orange, and then x equals 0 is the x-axis, or y equals 0 is the x-axis. This is terribly written. Yeah, it's supposed to be y equals 0. X equals 0 is the y-axis, y equals 0 is the x-axis. That puts us in the first quadrant, and we're dealing with a parabola shape because of the x squared for the quadratic function, and we're restricting ourselves between 0 and 2. All right, really all you need to do is set up the integral, but I think it helps to visualize what's going on. So for integrating this, so we know that's one of the rules I'm going to use, and then when we integrate 2, that's a constant. Integrating a constant gives you the constant times that variable. All right, these are the rules I'm going to apply. So for this, if I integrate, so if I factor out 5 and focus on integrating x squared, that's going to be 5 times, and then you do x to the 2 plus 1, so x cubed, and then divided by 2 plus 1. All right, that takes care of the x squared. Then integrating 2, that's a constant, so it becomes 2x. All right, and I put the brackets because we're dealing with a definite integral and going from 0 to 2. All right, so we have 5/3 x cubed plus 2x. So applying fundamental theorem, our f of b is f of 2, plugging in 2, that's 5/3 times 2 cubed plus 2 times 2. And then minus f of 0, and that's just going to give you 0, right? Because you do 5/3, 0 cubed is 0, times 5/3 is 0, and then plus 2 times 0 is 0. Right, that's the fundamental theorem. So this cancels out, and we just deal with 5/3 times 2 cubed, which is 8, and then we have basically 8 times 5 divided by 3, and then we add 4 to it, and you get 52/3. All right, that's our answer. That's the area. Again, this first part was just visualizing it. So the purple region, that area is 52/3. All right, right, now the next one is number 45. And all they tell us is that we have this y equals negative x squared plus 4x, and then y equals 0. Well, y equals 0, that's the x-axis. So at least we know we're going to be lying above the x-axis, but also this is going to be a parabola. And it's going to be a parabola that opens down because of the negative sign from the x squared. And technically you could write it as y equals negative 4 or x squared plus 4x plus 0. And you'll have the y-intercept is 0. And that's going to be 0, 0, right? When you plug 0 in for x, you get y is 0. So let's see. So I have the x-axis, which is y equals 0. I know one of my points, there's the y-intercept is 0, 0, so that's the origin here. And let's see, so it's either going to go like that, and it'll intersect at somewhere. So it's either going to go like that and intersect there, or it could technically go like this, dealing with the second quadrant. All right, so those are the two possibilities. Now what I want to do is just find, well, I know this is 0, 0. That's our starting point. A is 0. And then I need to find where does it hit the x-axis, or x-axis at the second point. And that's going to be my stopping point for integrating the area, or integrating to find the area. And that's going to be B. Or we could have our 0, 0 be B, and then A could be a negative value on the x-axis. All right, so I need to find where it intersects the x-axis. I mean, obviously we know one of them intersects at 0, but we need to know what's the other point. So since the x-axis is y equals 0, you set this equal to 0, so set the function itself equal to 0. And then I'm going to factor. So you could factor, I would factor out negative x. That's going to make x minus 4. And then you'd have the two cases, negative x equal to 0. That means x is 0. So we already know that because that was our y-intercept. And then x minus 4 equal to 0 gives us x equals 4. All right, these are my intersection points. All right, so 4 and 0. So I know now that it goes like this. And that's at 4, 0. All right, so I had to find that point 4 where it intersects the x-axis to do this problem. So we're running to find this purple region. And we can get it by doing the integration. A to b of f of x dx. our function f of x is that parabola. So negative x squared plus 4x, and we're going from 0 to 4. 0 is a, 4 is b. So we're doing the integral from 0 to 4, and then just integrating negative x squared plus 4x dx. All right, so we keep using our power rule for integrating. So first off, I would factor out the negative. So it'd be like negative 1 times, and then x, integrating x squared. That becomes x to the 2 plus 1 divided by 2 plus 1. Integrating 4x, well, you factor out the 4 and integrate x. X is x to the first power, so it'll be 4 times x to the 1 plus 1 divided by 1 plus 1. And then I have the brackets, so I'm dealing with the definite integral, and it goes from 0 to 4. All right, so what is that going to give me? So we have negative 1/3 x cubed. And then 4 divided by 2 is 2, so it'd be plus 2x squared. And then 0 to 4. So now I just applied fundamental theorem. So plug 4 in, that's your upper limit of integration, and then plug 0 in for x. Of course, when you plug 0 in, that's going to give you 0 because the only terms have x. All right, so that's our fundamental theorem. So do f of 4 minus f of 0. Okay, so that all goes away because that's 0. And when you calculate negative 1/3 times 4 cubed plus 2 times 4 squared, it's going to give you 32/3. All right, and that's the answer for this one. All right, so that's the area for that region, 32/3. All right, and that's where I'll stop it for this. And now we're done with section 4.4, and I'll start section 4.5 for the next couple videos.